Okay, we're going to look at the comparison of improper integrals today. This is section 7.7 from our textbook. The book does give a comparison theorem, which you can use all you wish. However, this was sometimes limiting in its situations. So here's an alternative theorem not found in our book. It's this little green thing says here. That's sometimes helpful. I'll do an example with it as well. This says if I have two positive continuous functions on the interval or the ray a to infinity, and if I have the limit of the ratio of those functions, if it exists as a positive and finite value, then looking at the two integrals, a to infinity of both f of x and g of x, both either converge or diverge. Then if I know the condition of one of them, if this one's convergent, that one's convergent. This one diverges, that one diverges, and vice versa. Why is that helpful? Well, here's an example where the one in the textbook will not be all that useful. The question is, does the integral from 7 to infinity of 1 over the square root of x cubed minus 5 dx converge or diverge? The book does an example like this on the class website, the video, where there's a plus here. And in that case, the one in the book does work, because if I look at 1 divided by the square root of x cubed plus 5, and I compare that to 1 over the square root of x cubed, since this denominator is bigger than this denominator, this expression is actually less than that one. This one equaling 1 over x to the 3 halves. And I'll also mention here, I want to discuss the p integrals, which says the following. The integral from a to infinity of 1 over x to the p dx, write this a little bit differently, converges if p is bigger than 1. It diverges if p is less than 1. Less than or equal to 1, actually. Also, we know the integral from 0 to a of 1 over x to the p dx. This is the reverse, converges if p is less than 1, diverges if p is greater than or equal to 1. And I keep these straight with the simple idea that this is the big interval. It converges for big P. This is the small interval. It converges for little p. Notice that in both cases, 1 does not work. That's illustrated in the textbook. So in this case, looking at a big interval with a big P in the bottom, this one's going to converge. Being less than a finite integral means this one also converges. But if I come through and make this example as it stands here and make this a minus, this bottom is now bigger than that, this bottom is now smaller than that bottom. I would flip this around. And this leads into the idea of the third point, which I was discussing, silly comparisons. The integral from 7 to infinity of 1 over the square root of x cubed minus 5 dx is greater than or equal to the integral from 7 to infinity of 1 over x to the 3 halves dx. I apologize for the dog barking. This is finite by the p integrals, but being bigger than or equal to a number doesn't tell me anything about this expression here. So we need a different attack. If I look at the limit as x approaches infinity of 1 divided by the square root of x cubed minus 5 over 1 divided by x to the 3 halves, the same comparison we tried to make before, you work this out, you should get 1. Quick work being shown there. This would equal the limit as x approaches infinity of x cubed under a square root over x cubed minus 5 under a square root, which is the limit as x approaches infinity of 1 divided by the square root of 1 minus 5 over x cubed. Doing a little bit of algebra there. Key point though, the bottom goes to 1 and therefore the ratio goes to 1. So that verifies this. So the key point, we can compare things to rational expressions looking at any kind of rational function or rational like function using the p integrals. So the idea was this basically looks like x to the 3 halves. So we'll do the limit comparison of it to actually set this up. And now we say, since the integral from 7 to infinity of 1 over x to the 3 halves dx converges, so does the integral from 7 to infinity of 1 divided by the square root of x cubed minus 5 dx. This notation, this would work with plus or a minus there, but the one in the book would not work if I had a plus there. One last thing to mention in this video, silly comparisons. We just saw one that says if you're bigger than or equal to a finite number, you've not learned anything. Another silly comparison is you do the direct comparison. Saying that you're less than or equal to an infinite value also tells you nothing. You could be equal to infinity or be finite and less than that. Thank you.